Alright, so with the Rust electricity update, there was a bunch of components introduced here that can do a variety of things, but I've had a couple people on some of the PvE servers that I'm playing on ask about how you actually use this stuff. Because intuitively, most people want to connect a variety of input sources, like hundreds of solar panels, into a bunch of batteries, and that just doesn't really work out as well as you would hope, because there are some limitations presently. One that's a bug and hopefully will be fixed, and another that maybe it may change as well. And the limitation and the bug that you need to know are that the combiners cannot be combined together. You can't plug one combiner into another combiner and take, for example, here I have two solar arrays going into a combiner to make one combined output source. And here I have two other solar arrays going into a combiner for another combined output source. But if you put both of these into another combiner, and I will prove this, you'll notice that when you connect them, they say empty, zero power. There was some kind of bug that I saw on Reddit, said something about it creating infinite power when they do this, or something about it enumerating the value, and blah blah blah. Long story short, you can't do that. And you can tell because you can still connect these to other things. Like I can go plug it into here. There's no power coming out of these. It's not making this combiner work. There's no power, nothing's coming through, nothing's working, so you cannot do that. The next best thing that I figured out how to do is to use an OR switch to choose the best power. So that's what this setup is going to explain. The other fundamental problem that you have right now is that if there is any output load on the battery, you can't charge it. And all of these switches and displays are output loads. So if you connect this battery to a switch or to a display or anything else here, it uses power. The one thing you can connect it to is a blocker. And that, if you turn it off, will let you charge the battery. So what this setup is going to do is show you how to take two solar arrays, and I've oriented them in different directions, and you may do this too to get better sun throughout the day, and a wind turbine, which sometimes is awesome and sometimes totally sucks, and use it as another power source, and have a setup that chooses the best possible power option. So first thing I'm going to do is take this solar array, plug it into this counter. I'm going to take this solar array, plug it into this counter. And these counters, if you hold E on them, you can set them to show pass-through, and that's what I'm using here. It's showing me how much power each of these arrays are putting out. This one's putting out more because it's oriented east to west, and on this builder server, the sun doesn't move from the west here. So I have two solar arrays right now. This one's better. If I connect them both to this OR switch, an OR switch only puts through one input, but it puts through the best one. So right now, this OR switch is putting through 41. So it's the 42 from the better array minus the little bit of power usage that this guy's using. I'm going to run this into this branch. The gray boxes are the branch. And the reason I'm going to use a branch here, I'll explain later, but it's so you can use the sun as a trigger to turn the lights on and off. So the right side of the branch is your main power output. So we got 42 coming in, we lose a little bit, we lose a little bit, we take 40 out of here. And I'm going to take this 40 output, and I'm running it over to this other OR switch. So this OR switch, one power source, is the better of the two solar arrays. The other source is going to be our wind turbine. So right now the wind turbine's putting out a lot, which is fantastic. So I'm going to just plug it into this display. And the displays here are totally unnecessary. I'm just doing them so you can see what's going on. So right now we're getting 125 out of the wind turbine. So in this case, the OR switch has to decide between 124 or whichever one this is choosing. In this case, the better is 42. So it's choosing between 42 and 124. So if I put this, again, into a branch, and I'll show you why in a moment, and connect it to this display, you can see our main power output right now is 105. So that's 123 minus the loss of this switch minus the loss of this branch. and I'm going to take our main power output here of 105. I'm going to run it down to this battery. So now I'm charging this battery. There's no output load, so it's charging. It's at 6 minutes, 26 seconds, and counting up. And it'll count up fairly rapidly right now because we're putting a whole boatload of juice here in. So now, what I'm going to show you how to do is how to tie the battery in here and make a decision on when to use the battery. So I'm going to take the battery output, and I'm going to plug it into this blocker. Now right now the blocker is on, so it's going to want to use this as a power load. So you can see the battery's going down. It's not charging anymore because it has a load. But what we can do is take this branch power, which is configurable, by the way. You could use a splitter too, which aren't configurable. But I'm going to go ahead and run it into here. And I'm going to take the main output of this branch, put it in here, take the battery, put it into the other side. And I'm going to take this branch, and I'm going to plug it into the blocker. Now, this is set to 2 right now. It really only needs to be 1. Any amount of power will do. If there's any power coming into the left side of this blocker, signal's blocked. It stops it. So you can see red light's on because there's power going through. That stops the load on the battery. So now the battery is charging again. What's happening right now is this is choosing the better of the 2 solar panels. This is choosing the better between the 42 and the 126. And this is taking 108 into the battery, and whatever we branch off of here, and sending it over to what I'll call our main power decision maker. So this is, do I want to take my live power from over here, or do I want to take power from the battery? Right now it only has the live power coming in, so it's choosing that. And I'm going to connect it up to this display so you can see how much is coming through. And it's putting through 10. And that's because I came over here to this branch and I changed it from the default of 2 to 15. Now, you can see we lose a bunch of power along the way here because only 10 makes it over here. But 10 is enough to run a handful of lights. Lights use about 2-ish units of power, best I can tell. So I could run 10 lights off of this thing right now if I want to. And the rest of the 106 is going to charge the battery up. Now, if the sun goes down and the wind stops, all of these are going to go to 0. There's going to be no power here, and that's going to turn the battery on. And then you're going to be getting battery output through here as your main output power. Now, one other thing I'm going to show you, the reason I kept that branch in at the beginning of the solar there, is how to use the solar as a switch. So you can see I got a lamp over here. But I'm not going to take this counter and plug it into the lamp. I'm going to plug the counter into the bottom of this blocker here. And I'm going to take the blocker and run it over to the lamp. Boom, lamp's on. Now, I put a switch on the wall here. It's just a regular old switch, manual switch. And I'm going to run it into the side of the blocker. Now, we're not putting any power in yet. But it will be as soon as I take this and run it over to the branch off the solar arrays. So now, if there's sun on either of these panels, it's going to be coming through here. Now, it's sending most of its power over to here to make the decision, but I'm taking a little bit off of here. We'll just set it to 1. That's all it really needs. And so since there's a little bit of solar power coming over here to this, it's blocking. So sun's out, lights off. If I use this switch, this is like your manual override switch here. If I turn that switch off, it's now no longer letting power through to the blocker and the light's on. So the light's on daylight, nighttime, anytime. It's the same as if I had wired it directly out of the counter here. But if I turn this back on again to allow the solar tap to come through, anytime there's sun, lights are off. So now, take a step back and just look at this whole setup overall again, and you can see you got 2 solar arrays coming in. This is the better of the 2 solar. Got the wind coming in. This is the better of the better solar versus the wind, and the wind's really good right now, so it's picking wind. I'm tapping 15 off of here for live power to send through to my light. which I'll use. I mean, you could be running other stuff that you actually want running during the day, then maybe you just get rid of this whole thing because you don't want it to be sun driven. Now what you'll see is battery's still charging, but if I take away some of these sources, so for example, if I, let me turn this back on so you can see what happens with the sun thing here. If I take away the sun, as it were, take away the 2 solar arrays, boom, no more power coming through here. Light turns on because the sun is down right now. By unplugging those, it's the same as the sun being down. So it's running off the windmill. If I take away the windmill, boom, no more power through here to run the blocker. Blocker's not triggered. Now it's using the battery. Battery's counting down. Now, battery's putting out 7, lights on, sun is down as it were. All of our power is cut off here. If I plug any of this back in again, now it's as if the sun was up again. So boom, now we have sun power. Turns off the light because the sun's out. And starts charging the battery again because there's power going through the main branch. Can hook up the windmill. Boom, now we got lots of power coming through. A lot faster battery charging. And boom. I'll take a step back so you can get all of this in for your reference. But this is how you use 2 solar arrays plus a wind turbine to get power, whether it's daytime or nighttime, and leverage those solar array input as a trigger for turning lights on and off based on the sun. You can swap out a large battery here. You can use splitters instead of branches if you wanted even power coming out between right here. If you replace this with a splitter, then it'll evenly split the power between your live power and your battery. The reason I like to use the branch here is because if I know I'm going to need 10 power to run my stuff during the day, I can set this to a certain value. If I know I'm going to need 20, I can set it to a higher value. And effectively, your leftover power, which is what we see coming out the top here, 65, goes to charging the battery. Don't make your workload higher than your input, or you'll never have any power left over for your battery. And that, my friends, is that.